Today we are going to start section 3, chapter 1, which is about the cause of circular motion. Yes, in section 2 we'll learn that if an object moves on a circular path, that object will experience a centripetal acceleration. And according to the second law of motion, if there is an acceleration, some force must cause this acceleration. Now in this section we are going to talk about that force known as a centripetal force. So first, assume that there is a car moving on a circular track with constant tangential speed. So tangential speed is constant, 30, 30, 30. So it's 30 all along this circular track. But while it's moving with this constant tangential speed, its tangential acceleration is 0. However, direction of car is continuously changing. Direction of motion of the car is continuously changing. That's why this car experiences an acceleration, which is known as centripetal acceleration. And according to the Newton's second law of motion, whenever an object experiences an acceleration, there must be a resultant force acting on that object, which produces this acceleration. That force, that resultant force, acting on this object and produces this acceleration, which is known as centripetal acceleration, is called centripetal force. As you see, both has a description, centripetal. Centripetal, remember, its meaning is towards the center. It shows the direction of acceleration. Also, it's going to be explaining direction of that resultant force. That resultant force acting the object will point towards the center. Now I will explain the centripetal force a little detailed. First, its direction, as I said, is towards the center of the circle, just as this centripetal acceleration, because according to the Newton's second law of motion, mass multiplied by acceleration is the force, and acceleration is a vector quantity, force is the resultant force is a vector quantity, mass is a scalar quantity. So if you multiply a scalar by a vector or vector by a scalar, result is a vector. That's why these two quantities, force and acceleration, will be in the same direction. That's why resultant force, that resultant force which causes this car to move on the circular path, will be in the same direction of centripetal acceleration. And we know that centripetal acceleration is acting towards the center, so along the radius, and that's why centripetal force also must act along the radius towards the center. And this equation, in fact, second law of motion, and also known as Newton's second law for circular motion. And this force which keeps the object on a circular path can be a single force acting on the object, so such as gravitational force or tension force, electrostatic force, or friction force. So it is not a centripetal force is not a kind of force. It can be any type of force which keeps the object on the circular path. General name of that force is centripetal force. So for example, gravitational force acts on the moon and the moon revolves around the earth. Or tension force, we will talk about later. You can swing an object attached to a rope and on a circular path with that tension force. Or electrostatic force, you learn in the 11th grade. So electrons are revolving around the nucleus, so the force which keeps these electrons around the nucleus is the electrostatic force. Or you are going to learn in chapter 5, so when a charged particle enters inside a magnetic field, it moves on a circular path, and that force keeps this charged particle on a circular path. Magnetic force, you will learn in chapter 5. So any force, any single force, so acting on an object and keeping that object on a circular path, can be a centripetal force. But sometimes more than one force can act on the object. In this case, we are going to calculate the resultant of those forces. So it could be the resultant of more than one force acting on an object. We will study this in details in the second part of this title. So that's why definition of the centripetal force is given as, it is defined as the resultant. Yes, So it can be single force or it can be multiple forces acting on the object. Resultant. That's why we should calculate the resultant. Effective force. What does effective mean? We will explain. I will explain later. But this effective has an important function in this sentence. Resultant effective force on a body that moves in a circular path, and this resultant force will be directed to the center of that circular path. This is the definition of centripetal force, or the force that maintains circular motion of an object. And of course, calculate the magnitude of the centripetal force. So it's not so hard. Just we are going to use Newton's second law for motion. The magnitude of this force can be found by applying Newton's second law. What is Newton's second law tells you? So resultant force acting on the object, which is a centripetal force, is equal to mass of the object multiplied by centripetal acceleration. Fc is equal to mass times AC. And centripetal acceleration can be written in two alternative forms depending on tangential speed is given in the question or angular speed is given in the question. If tangential speed is given in the question, you are going to use this equation mvt squared over r. But if the angular speed is given in the question, you are going to write this equation mr omega squared. But in fact, both are defining this, so we only insert equivalent equation of centripetal force in here or right here, depending on its tangential speed or angular speed. So always you will calculate the force as in Newton. This is the definition of centripetal force, and this is how we calculate the centripetal force. Now we will continue with some problems. For example, sample problem 1H. A pilot is flying a small plane at 30 meters per second. So this is tangential speed, meter per second. Remember, tangential speed was linear speed, and linear speed is measured by meters. So 30 meters per second is tangential speed, while this airplane is flying along this circle. So it's going to be 30 meters per second. In a circular path with a radius of 100 meters. So radius of the circular path is given as 100 meters. If a force of 635 Newton is needed to maintain pilot's circular motion, that force is the force acting on the pilot and maintain circular motion of that pilot. So it must be, of course, centripetal force, because force that maintains circular motion is called centripetal force. So it is 635 Newton. What is pilot's mass? Question is calculate the mass of pilot. So let's write the given in here very clear. Vt tangential speed of the plane, also the same as the pilot. Pilot is also moving together with the plane. So it is 30 meters per second. Radius of the circle the pilot's body and the plane's body follows is 100 meters. And centripetal force keeping the pilot's body on a circular path is 635 newtons. So calculate mass of the pilot. So the thing we should do is to use the equation of centripetal force, which is Fc is equal to mass times tangential speed squared divided by radius. So we will calculate the mass. That's why this equation calculates centripetal force, but we need to calculate the mass of the pilot. That's why we have to rearrange this equation. How? So there are multiple waves. One quick wave is this ratio in here, Vt squared over r. It's on the right side of the equation, and then if you take it to the left side, it will flip. You are going to flip this ratio like that. R over Vt squared multiplied by Fc is equal to mass, or you can use cross product, even you can continue that way. So this is how we calculate the mass. So let's calculate the mass. R is given as 100, 100 meters multiplied by centripetal force is 635 newtons divided by Vt squared, which is 30 but squared. So answer of this question will be, let's go to the calculator, 100 multiplied by 635 divided by 30 squared, which is 900, is equal to 70. Yeah, 70.5 kilograms is the mass of the pilot. And we will continue with another problem. It's a car, a 905 Newton car, travels around a 3.25 kilometer circular track. So this is the mass of the car, M, and this car travels around the circular track, 3.25 kilometer circular track. If the magnitude of the force maintains car circular motion, so the force that maintains circular motion is called centripetal force. So this is the centripetal force acting on the car. What is car's tangential speed? Calculate Vt, tangential speed of the car. So in here, general mistake is done in this expression, this description. It is what 3.25 kilometer circular track. So this is not defining the radius, this is not defining diameter, it's defining the length of the circular path, which is the circumference. 3.25 kilometer is not radius, not diameter, it's defining the length of the circular track or circumference of that circular track. So it is the arc length for one revolution, in fact. So S is equal to 3.25 kilometers. But this kilometer is not a SI unit, that's why we have to convert kilometer to meters. How? By multiplying 1000. By multiplying 1000, we will convert kilometer to meter. Centripetal force is given as 2,140 newtons. So calculate Vt. So as I said, first we should calculate the radius, but first you should calculate this circumference into meter. So S is equal to, we know that every 1 kilometer is 1000 meters. So we should write in here 1000. We should multiply 3.25 with 1000. We will get the result as 3,250 meters as the circumference or arc length for one revolution. And then use now definition of the circumference, which is 2 pi r. So S is given 3,250. 2 pi is 6.28 multiplied by r. So simplify by dividing 2.28 because we need to know what r is. So then you will divide 3,250 divided by 6.28. It's going to be 517.5. So 517.5 meters. This is the radius of the circular path. Now we are ready for calculating the centripetal force, because centripetal force in here, we will continue tangential speed, but we will use the centripetal force equation, Vt squared over r. So we need to know what Vt is. So cross product in here is 1 multiplied by mvt squared is mvt squared is equal to r times fc. We will calculate Vt, that's why we have to divide, simplify m. So m will be simplified, and then we will get Vt squared as r times fc divided by m. Next step is to get the square root of the both side of this equation. So then we will get Vt as root of r fc divided by mass. And then insert the given into the equation, but don't forget to use the bracket. So r is, we just calculated 517.5 multiplied by centripetal force 2,140 divided by mass of the car is 905. Close the bracket. So answer, let's do it. Root of bracket 517.5 multiplied by 2,140 divided by 905. Close the bracket. It's equal to 35 meter per second. Yes, almost 35 meter per second. This is the tangential speed of the car while it's turning this track, this 3.25 kilometer circular track. So this is the practice problem number 2. This is a bit harder compared, because of that given definition is a bit sometimes students are making mistake, but be careful. It's not radius, it is the circumference or length of the circle. And one chapter review question, again, generally students get a bit confused with the problem, but just the problem explanation. It's this: an airplane is flying a horizontal circle at speed of 105 meters per second. This is the linear speed, and linear speed on a circular path is called, remember, tangential speed. The 80 kilogram pilot, so this is the mass of the pilot, M, does not want the centripetal force, centripetal acceleration, to exceed 7 times free fall acceleration. So while the airplane is turning on a horizontal circle, of course, the pilot is also moving on that circular path, and as it's turning on a circular path, its body experiences centripetal acceleration as every object while they are turning on a circular path. That's why this pilot's centripetal acceleration mustn't be greater than, not exceed. Not to exceed means it mustn't be greater than, not greater than what? 7 times multiplied free fall acceleration g, and 7g, it will be maximum 7g. G is the 9.81, remember. That's why, so this is the only thing just students sometimes get difficulty. So centripetal acceleration of the pilot will not be greater than 7 times free fall acceleration, and 7g, which means it will be maximum 7g. It's also about the health, because if the human body can experience an acceleration greater than 7g, so the body can get some high pressure, blood pressure can increase, heart attacks can be possible. That's why they say it mustn't exceed 7 times free fall acceleration. So Vt is 105 meters per second tangential speed, so mass is given 80 kilogram. So centripetal acceleration will be maximum 7g, not greater than that, and we know that 7g is 7 times 9.81. It's going to be, if we calculate them, 7 times 9.81, it's going to be 68.67. So 68.7 meters per second square maximum centripetal acceleration that pilot's body bear is this number. So find the minimum radius of the plane's path, calculate r. So r is the question in here. And then we know what centripetal acceleration, that's why we are going to centripetal acceleration definition. AC is equal to V tangential speed squared over r. But this equation calculates AC, but AC is given. We need to calculate r, cross product. So simply I told you to change the position of AC and r, because AC times r or r times AC, they have the same meaning, say equivalent result. That's why r is going to be Vt squared over AC. And Vt is 105, but squared divided by AC is 68.7. So let's use the calculator. 105 squared divided by 68.7, which is going to be 160 almost, yeah, 160 meters is the radius of this, minimum radius of this plane's path. And part B is asking about at this radius, what is the net force that maintains a circular motion exerted on the pilot's body by the seat belts, friction against the seat, and so forth? Of course, while this pilot is moving on a circular path, there must be a resultant force acting on pilot's body. That resultant force is centripetal force, as you know. So, of course, this sentences are talking about the origin of this centripetal force. What is the origin of them? So we are going to use this second law of motion, circular motion, because we know what AC is, we know what mass is. Mass is given 80 kilogram for pilot multiplied by centripetal acceleration 68.7. So when we multiply them, we will get the result, which is 80 multiplied by 68.7, which is going to be 5,496 Newton is the centripetal force, or the force resultant force, acting on the pilot's body while this airplane is flying in this horizontal circle. And this is all about the question about centripetal force, first part. But until here we are given only one centripetal force, or just resultant force is given. But now there are other problems. We can also calculate if there are more than one forces acting on the an object. So we will start this part. Now I will again remind you the centripetal force definition. It's defined as the resultant. Yes, always we are going to calculate resultant effective force on a body that moves in a circular path and directed to the center of the circular path. What does it mean? So resultant is directed to the center, but sometimes force can be in towards the center, but some force can be out of the center. We will show these cases. The first one is, I will explain this definition a little in detail. One of them is any type of force can be a centripetal force, or which affects a centripetal force, or any component of the force. I will explain this part in later, but you are going to be careful about this. Which lies along the radius affects the centripetal force. So the force itself, or the component of the force, must lie along the radius, must be on the radius. So then we can say that that force or that component affects the centripetal force. One of them is best example is this example. While you are rotating or swinging an object attached to a rope on a horizontal circle, of course there is a tension in the string, and this tension provides the force, centripetal force, and tension acts along the rope always, and then pulls the object, this ball, towards the center. And in here, just one single force is acting on the ball, which is the tension force. Tension force is the centripetal force. That's why only centripetal force in here is this tension force, Ft. So then you can say that if a force, just one single force acts on an object, and then this single force is towards the center, so that force is going to be the centripetal force. But sometimes there can be more than one force acting on the object. So just like this one, there are two forces now acting on this ball, and then this ball is both forces are towards the center. So in this case, you are going to calculate their resultant. So both are pointing the center. So if the forces are pointing the center, write them positive. Because they positively affects the centripetal force. So Fc is going to be in this case F1 plus F2. But what if one of the force is out of the center, I mean away from the center, just like this one? In this case, F3 will affect the centripetal force in a negative way. So F1 is positive towards the center, F2 is positive towards the center, but F3 is away from the center, so negative. In this case, the resultant force will be calculated by F1 plus F2 minus F3. So what if there's a force perpendicular to the radius like that? So this is important because remember in the equation there is resultant as a word, so we find resultant but effective. So any force which is perpendicular to the radius is not effective. They do not affect the centripetal force. And here F4 is perpendicular to the radius. That's why F4 will not be included in the centripetal force. Again, in here you are going to calculate the centripetal force by F1 plus F2 minus F3, but F4 will not include because F4 is not effective force. So any force perpendicular to radius does not contribute to centripetal force because they are any force perpendicular to radius is ineffective force. So that's why this definition is given. This word is put in the definition of the centripetal force. So always we are going to say that if any force or any component of the force perpendicular to radius, that force is ineffective, so it will not include in the centripetal force equation. So, but sometimes force can be inclined. We are going to study this case in one of the conceptual challenge. So in this case, like this F1, if the force is inclined like a swinging ball in a horizontal circle, but the rope is inclined. So in this case, you will look for the components. So remember in here written any component of the force. So let's draw the component of F1. There are two components. One of them is the horizontal component, F1x. The other one is vertical component, F1y. And if you see that, one component is pointing the center along the radius, so this is effective. F1x is effective and it points the center. That's why it positively affects the centripetal force. But F1y is perpendicular to radius, so this F1y is ineffective. So that's why F1y will not be in your centripetal force equation. So Fc is going to be F1x. For this case, x component of the force, the component of the force towards the center of the circular path will be the centripetal force in here. Now we are going to solve some exercises, some problems about these cases. For example, this is one of the chapter 2 question. Question tells you that a girl at the state fair swings a ball in a vertical circle. Yani like this one, this is a vertical circle. And at the end of the string, ball is say this is the ball. It is at the end of the string, and this ball is swinging, moving on a vertical circle. Is the force applied by the string? Yes, of course. This string will apply some force on the ball while it's swinging. Is the force applied by the string greater than the weight of the ball at the bottom of the ball's path? So this ball will go down. So questions about the bottom, question about in here. I draw the model on the right side. So two forces will be acting on the ball when it's at the bottom. One of them is the gravitational force, and we know that gravitational force always acts towards the center downward. So Fg. Second one is the force applied by the string. So in which direction is the string pulling the object? It's upward. String is upward direction. That's why the tension force, which is called the force applied by the string, name is tension force. Tension force is acting upward. And tension force provides, remember, the force which is towards the center provides a positive contribution, but away from the center, negative contribution. So then when we calculate the result is going to be centripetal force, which is Fc is equal to Ft minus Fg. So if Ft minus Fg, which means Ft must be greater than Fg, and then in this case only you can get a resultant force. And one way is this, or you can write equation like this: Ft is going to be Fc plus Fg. So you are adding F to Fg and Fc and another number to get Ft. That's why Ft must be greater than Fg. Or in common, you can think this way: the force which points the center will be greater than the force which is away from the center. So that's why Ft must be greater than Fg. And we can change this question in alternative form like this. At the top of the let's change this. Let's make an additional question. The girls at the state fair swings a ball in vertical circle at the end of a string. Is the direction and the magnitude of the centripetal force? What is the direction of the and magnitude of the centripetal force at the top? Now this time let's do it at the top. So at the top of the circular path, again, there are two forces acting on the ball. One of them is gravitational force, as usual, downward. And the tension force, or the force applied by the string, is along the string. It's downward as well. Now both forces are downward. That's why both will positively affect the centripetal force. So in this case, you are going to write in here Fc is equal to Ft plus Fg at the top. What if you take this ball when this big ball comes in here at this position? So again, two forces acts on the ball. One of them is Ft, but Ft this time acts to the right. So because the center is on the right, so Ft becomes like this. What about Fg? Fg is downward always. But in here, Fg is not effective because it's acting on the perpendicular to radius, not effective. In here, that's why only at this position, centripetal force will be the tension force by the string. Or at this position, when when the ball comes in here, again, Ft this time to the left, Fg is again down. You can never change direction of the gravitational force. It's downward always. Again, Fg in here is not the effective force. The only effective force in here is the Ft tension force, or the force by the string. So it's to the left this time. So direction of the Ft is changing, but in here it's to the right, in here to the left. But at these two positions, only centripetal force acting on the object is Ft. So let's solve one of the chapter question. It's about the roller coaster car. Again, roller coaster. This is an example in vertical circle. A roller coaster car speeds down a hill past point A and then rolls up the hill past point B as shown in figure. This figure is given in the book, just exactly like this. The car has a speed of 20 meters per second at point A. This is the point A. While car passes this point A, so its speed is tangential speed, of course. Vt is 20 meters per second. What is the mass of the car? So, 20 meters per second. If the resultant force on the car is 2.06 times 10 to the power of 4 Newton at this point, at point A, the resultant force acting on the car, and remember, resultant force acting on the car is what? Centripetal force, Fc. 2.06 times 10 to the power of 4 Newton. This is centripetal force at point B, at point A, sorry. What is mass of the car? Mass is the question in here. And we know that centripetal force always towards the center, resultant force, and points towards the center. That's why it must be acting towards the center on the car. And its value is 2000, if you multiply 10 to the power 2, 20,600 newtons. So, radius of this circular path is given as 10 meters. Tangential speed is given 20 meters per second. Centripetal force is 2.06 times 10 to the power of 4 Newton, which is 20,600 Newton. Calculate mass of the car. Use the equation for centripetal force mvt squared over r. We'll calculate m, flip this equation, and we'll first continue with cross product. Mvt squared is equal to r times fc. These two will multiply, but because you are going to calculate m, divide by vt squared, divide by vt squared, and simplify vt squared on the left side, and you will get mass as r fc divided by vt squared. R is given, fc is given, vt is given. Just insert into the equation and calculate the result, which is 515 kilogram. It is the mass of the roller coaster car. And this question is in a B part. Now let's continue with the B part. B part tells you what is the maximum speed of the car can have at point B. Now, of course, this car will go down to A and after that roll up B. This is B. So what is the maximum speed of the car can have? Of course, it's talking about the tangential speed in here. So what is the maximum speed the car can have at point B for gravitational force to hold it on the track? In here, this definition is very important. For gravitational force to hold it on the track, which says you that at point B, the only force which affects the gravitational centripetal force is the gravitational force. The sentence tells you. So R is in here in this circle is a little greater. So in the small circle, A was a little small circle, and B it's a big circle. It's 15. So mass is given, mass we calculated 515. If needed, we are going to use it. Tangential speed is what at point B, we will calculate that. As I said, if the gravitational force is to hold the car on the track, so which means gravitational force is the only centripetal force, only force which contributes or affects the centripetal force. So that's why we are going to make them equal. Centripetal force is equal to gravitational force, yani Fg at the point B. So, right, Fc and Fg, Fc is mvt squared over r, Fg is m times g, Of course, this m and that m will cancel out. So VT squared over r is equal to g cross product. So cross product r and g. So VT squared is equal to rg. Then after that, get the root of this both side of the equation. You will get VT as root of rg. And r is given 50 meters. G is given 9.81. So when you calculate with calculator, you will get the result as 12.1 meters per second. So the maximum speed the car can have in here is 12.1 meter per second. What does this 12.1 mean? So the car can get this maximum speed at that point if it is greater than that speed. If a car has a tangential speed greater than 12.1, car cannot follow the circular track. It will be off the road. It will move with a larger radius, so it will not stay on the road. But if it is less than 12.1 or equal to 12.1 meters per second, still the car is on the track. That's why it's called the maximum speed. So this is all for the first part of the centripetal force. We will continue with horizontal cases of some chapter questions in the next lesson. Also, I am going to define the inertia and centripetal force equation in the next lesson. So this is all for today.